Chrystalina, thank you very much for talking to us today. And why do you think it is the circle of Willis is called the circle of Willis today?
Okay, so let me start from the neurology area, which is my area of specialty. Thomas Willis can claim to be the father of neurology, and that is essentially the study of and treatment of the nervous system. And Willis was a fine anatomist. He was celebrated for his dissections of the brain and of the cranial and spinal nerves. And his writings, in fact, which include the first use of the word neurology itself, you can sort of trace it back to the Oxford English Dictionary, which records actually Willis as the first person to have used the word neurology in print. And to my great interest, being a Greek Cypriot myself, in cerebral anatomy, the term appears in Greek as neurologia, which is neuro and logos, which is the English, the Greek side of neurology, really. And in fact, if you read, I've got a little extract from Samuel Poldrudge, 1681 English translation of Willis' complete work states, "Our method demands of us that by the sense or numbering of the nerves being particularly made, we should deliver an exact neurology or doctrine of the nerves." So going back to your original question, it's almost nearly 400 years, in 1664, when Willis produced the most detailed anatomic description of the arterial anastomosis at the base of the brain. The circle of Willis is the name given to a ring of blood vessels, essentially on the skull base, that connects the main intracerebral blood vessels that supply the brain. It is closely related to other important structures, including the stalk of the pituitary gland and optic chiasma. So the video on the left-hand side of the screen here shows the three-dimensional image of the blood vessels of the brain, known as an angiogram. And the static image on the right shows the location of important structures, including the circle of Willis. So 4 arteries, the left and right carotid, I hope you can see my points here, and then the left and right vertebral arteries here, you can see the smaller one here, supply blood to the brain. And the carotids run along either side of the front of the neck, and each carotid artery branches into the internal and external artery. Each internal carotid artery passes into the cranium and then branches into the anterior and middle cerebral arteries that you can see up here. And then each of these internal artery passes into the cranium, then branch into the anterior and middle cerebral arteries, and then the left and right anterior cerebral arteries and the anterior communicating artery that joins them, you can see here, form the front of the circle of Willis here. The 2 vertebral arteries ascend alongside the cervical spine, and once inside the skull, unite to form the basilar artery, which again is noted here. And that supplies essentially the brainstem before splitting again to form the posterior cerebral arteries, the most posterior part of the center, the circle of Willis. The circle is completed by the posterior communicating arteries that link the internal carotid arteries to the posterior cerebral arteries. And it's interesting, and a lot of people usually ask us about this when we talk about the circle of Willis. Although a complete circle of Willis is present in many individuals that we see, anatomical variations tend to be really common, and the ring is frequently incomplete, what we actually see in this particular angiogram here. In this angiogram, I want to point something out that I found out recently myself. There is another variation. So the left vertebral artery does not contribute to the basilar artery, meaning that the right vertebral artery, which is clearly larger, provides all of the blood supply to the basilar artery, and that's the posterior part of the circle of Willis. That's the one here. You can see is much thinner. And extends down to here, and it should be sort of this size here on the right hand side. This is the left and this is the right, and you can see that it's also thin, is shorter, it doesn't go and doesn't contribute to the basal artery. So all the supply in this particular patient here is coming from the right hand side. The circle may provide a means of for collateral blood flow in the event that one of the major blood vessels feeding the brain gets narrowed by, for instance, atheroma, and possibly preventing strokes. That has been extremely useful in terms of the neuroanatomy, sort of going into the clinical aspects. But it has a dark side, if you like, to this. Too many junctions between the vessels that form the ring that we see here are potential weak spots where you can have bulges called aneurysm that can form, particularly in people that experience high blood pressure for a prolonged period of time. And this can sometimes rupture, and these ruptures could cause life-threatening subarachnoid brain hemorrhages. So angiograms, like the one we are discussing here today, are a vital modern tool in visualizing essentially any abnormality and planning surgery to treat it, which is what our neurosurgical colleagues do on a daily basis. And they have developed over the years a number of different techniques to perfect the way that this is done. So I think we could reasonably coin Thomas Willis with this fantastic sort of anatomy, if you like, and the illustrations that we see here, you know, reflected in a real flesh angiogram from a real patient. And we could easily argue that without this information, we would have had people having subarachnoid brain hemorrhages, aneurysm that would be there and causing, you know, life-threatening conditions without knowing exactly what the cause for this is.
So Willis didn't have digitally subtracted angiograms like the ones you are showing here of the vertebro-basilar system and the carotid system. So he didn't have this. So how did he discover the circle of Willis?
Yeah, he had though, I think, a beautiful soul and a beautiful hand and brain that was able to produce quite descriptive, if not the most beautiful, if you like, drawings. But he was able to put down what we couldn't see, they couldn't see at the age without angiograms and modern, you know, technology and functional imaging, for instance.
So he dissected, and then he could see all these variations, and he immediately understood the physiological relevance of these variations. That's right. And I think in his case, he had a case where there was one of the internal carotid arteries had an occlusion, and then he was puzzled why that patient who actually died from an intestinal tumor had no neurological symptoms, whereas he was missing the supply from the one side in the internal carotid artery. So he was way ahead of his time.
Absolutely, and I guess that's why you teach all the, you know, dissection rooms and all the things that we do in Oxford, really, isn't it, in terms of our preclinical students trying to understand how to understand themselves before moving on into the modern technology, really, because if you don't go into a dissection room and if you don't know what you're looking at in terms of anatomy, I guess you miss the point of understanding the essentials of how anatomically important various bits and pieces are.
And this was also actually one of the huge virtues of Willis, because he never believed anything which he did not see. So exactly. So he always questioned the dogmas. So it wasn't Willis who was first to describe the circle. There were many others, Italians, Dutch, also Swiss researchers described this before him. So why is it still called the circle of Willis?
Because he was the first one to actually relate it to clinical medicine and make it relevant, really. That's what we talk about, the relevance between what he was looking during his dissection years, really, and the actual translational aspect. I think this is one of the most beautiful early ideas of translational research and clinical, you know, into clinical medicine, really, which he was the first one to do and understand how important this bilateral communication, if you like, was to be able to see something and then project into what was important in the clinical world.
Mm. And also, probably it also helped that Christopher Wren helped him with the illustrations, which were extremely beautiful and compelling, and we could even use them today. So, Cristalina, the word neurology or neurologia was published first in this book. Mm-hmm. So, what is the origin of this word?
Well, you're asking the right person, because I have found out that it comes from my native language, which is Greek, neurologia, which is neuros and logos, which is the Greek translation, if you like, of neurologia. It goes into Latin and then neurology into the English translation. And in fact, the first time that people have seen it in print is in this beautiful book that we see here, the Cerebral Anatomy.
Excellent. So this was the first time when it appeared. Apparently this was like printed in 1663, but it's published in 1664.
That's right.
And this publication is also famous because of this drawing. So can you tell us a little bit about this?
Absolutely. So this is very much the beautiful drawing that we usually, we use to teach our medical students. Let's just go through a little bit through the basic anatomy here. So you've got 4 arteries, the left and the right, carotid, and then the left and the right vertebral arteries that supply blood to the brain. The carotids run along either side of the front of the neck, and each carotid artery branches into the internal and the external carotid artery. Each internal carotid artery passes into the cranium and then branches into anterior and middle cerebral arteries. The left and right anterior cerebral arteries, and then the anterior communicating artery that joins them, form the front part of the circle of Willis. The 2 vertebral arteries ascend alongside the cervical spine, and once inside the skull, unite to form the basal artery that supplies the brainstem before splitting again to form the posterior cerebral arteries, the most posterior part of the circle of Willis. The circle is completed by the posterior communicating arteries that link the internal carotid arteries to the posterior cerebral arteries. And you could have complete circle of Willis that you see here, both on the left figure and on the right figure. But the reality is that anatomical variations are very common, and the ring that we see in both pictures here is very often incomplete, really, which is the beauty of it, really, of anatomy, how special and different we are, from person to person.
And probably this circle is a little bit exaggerated, because it's very unusual to find so strong posterior communicating, and also usually you have a small anterior communicating, so there is no such fusion. But anyway, they emphasize this. And the person who is responsible for this is actually Christopher Wren, who was also a fantastic architect. So the Sheldonian Theatre was designed by Christopher Wren, the All Souls College, this quadrangle. And so he was responsible for all this, and he was actually acknowledged in the preface of in the first page of the Cerebral Anatomy by Willis. So and probably that's why the name is associated. So Willis should be credited for all this. So he produced the first acceptable illustration, made the second good or third or fourth good description, no matter how you count it, and then he correctly summarized the physiological importance, and I think, and also had some illustrations, case reports, showing the clinical relevance. So that's why. So these were the others who described some aspects of the circle, and Johann Jakob Wepfer from Switzerland had a very good description, but no illustration. So Willis that's why it's called Circle of Willis. And this is, which you just described here. You have the internal carotid system, and then you have the anterior and the middle cerebral arteries, and here you have the vertebro-basilar system, the two vertebral arteries, they join to basilar artery, and then you will have the posterior. So I also have some old-fashioned angiograms, not as nice as yours, you showed us, which was digitally subtracted, and then you can see the carotid artery coming into the skull, and then you have the two end branches, the anterior and the middle cerebral artery. So the anterior is running in the midline above the corpus callosum. You can almost see the silhouette. And in the anteroposterior view, you can see this, that the anterior comes to the midline and running there, whereas the middle cerebral will run to the convexity between the temporal and the parietal cortex. So this is more similar to the one you showed, the digitally subtraction. So this is the anterior. The patient is facing us, and we have the left carotid, internal carotid field, and you can see the mid cerebral artery, and then this is the anterior cerebral artery. Mm-hmm. And the vertebro-basilar system, here, this is the anterior view, and this is the lateral view. So this is the occipital region, and you can see the vertebral artery, the posterior cerebral, and then you have the posterior inferior and the superior cerebellar arteries coming here. So Willis got it all this right. He didn't have the angiograms, but he got this right with perhaps with some exaggerations, which Trevor Hughes describes in his books. Some of the small inaccuracies. Like Trevor Hughes said that you should have had more pontine blood vessels here. Usually the anterior spinal is coming from the two vertebral and then uniting, so not like this. Mm-hmm. But these are minor, minor differences, and also perhaps this is exaggerated how thick this posterior communicating artery is, although you can have these variations. And the fusion of the anterior cerebral is a bit also exaggerated. And Willis also showed it in sheep. So here you can see it in a sheep, mm-hmm. and here in human. So he is a giant.
It's very interesting, Zoltan. I think that's absolutely beautifully what you're describing here. And I think is what's more interesting, I'm just thinking about all the other people you're listing there that have come prior to Thomas Willis, but probably we wouldn't even know about them. I wouldn't even have read about them had I not researched a little bit into Willis to see who the previous people were. But it goes to show that good illustrations and good, beautiful drawings that him and obviously Christopher Wren have produced, like you very nicely described, go a long way. And I guess it's people like Leonardo da Vinci, a polymath, who was able to do all the different things, combine engineering with the beautiful drawings and everything else that can create the translational aspect that we see today. And it's essentially what we're doing, isn't it, with our respective sort of areas, being able to do figures. Maybe they're electronically now, we might not draw them by hand, but it's very much about being able to show beautifully and very clearly something that is so complicated, which if you think about it, how he came to explain it in such simple ways was not an easy road for him to do so.
So there is a message for us today. Then we have to aim for clarity in illustrations, put in the time to do the drawings, because then the message will be clearer. Yeah.
And as we know, a picture is 1,000 words, isn't it? And in Greek, we always say this, that a beautiful, painting, we go to our beautiful museums here in Oxford, there's not a lot you want to hear about. You just want to absorb the beauty of something. And I guess the drawings by Christopher Wren, to my mind, are just beautiful to watch. Even if you're not a scientist, if you're not a medical doctor, if you don't understand the ins and outs of what you and I have just been talking about, it's very much about an aesthetic product that it's so nicely done. It's almost like food for the soul, we say, φαγητό για τη ζωή, which is what they say.
But I have a confession to make. I don't find it comfortable to read in Latin, although I was tortured before and during medical school. We had to learn Latin, but I always look at the pictures. And I also, for instance, I find it Vesalius illustrations are so artistic and But also some of Willis's illustrations are extremely schematic. So, for instance, the autonomic nervous system, that illustration is almost modern, and you could teach the autonomic nervous system from those drawings. But probably those drawings were made by Richard Lauer, his student, rather than by Christopher Wren.
Sure. That's very interesting. Yeah. Brilliant.